Hello everyone. As I told in my lecture that I will upload some videos on assignment because some people could not get clearly about assignment discussion. So I will be quick, so the video will be short. In our assignment, the first question was about counting. It was not almost exactly the same what we have discussed in the class. In class, we did it before 6 people. Over here we are doing for 10 people, right? So the very first question is how many handshakes? So when one person comes, he handshakes with the rest of the people. If there are 10 people, so the very first person he has to shake with 9 people. Second person he will shake hand with 9 people. Third person he will handshake with 9 people. So total handshakes we can see 10 into 9. But each shake involves 2 people. So it means we have to divide it by 2, not to do double counting. So we had already found formula for this thing. So it was n into n minus 1 divided by 2. So you just have to put the value of n, which is 10. You will get the answer. Let's come to the second question, which is more involved. How many seating arrangements are possible for 10 people? In the class we did it with 6 people. You people found the answer, it was 6 factorial. So obviously answer is clear here. That the first person, he has how many choices? He has 10 choices to sit. There are 10 seats, so he can sit any one of those seats. Now one seat is occupied, the second person will have 9 choices. So he can sit in 9 choices and one of the 9 seats. So total seats are 10 into 9. So next person, he is going to sit one of the 8 seats. And next person one of the 7 seats. Next person one of the 6 seats, and so on till the last guy will have only one choice. So answer is 10 factorial. This is pretty much easy. The last point is interesting. Like they are now sitting to play chess. So each board will have 2 players. So there are how many boards we have? We are going to have 5 chess boards. 10 players, so we need 5 boards. Fine. So on each board there are 2 players. 1, 2, 3, 4 and 5 boards. And just name them for our convenience. A, B, C, D, E. These are names of the board. So players sitting, player 1, player 2, player 3, player 4, player 5, player 6, player 7, player 8, player 9, player 10. So how many seating arrangements are possible? This is exactly the same as part B. So there are 10 factorial seating arrangements are possible. But if we change the boards, it will remain the same match. The match will not be affected because if I move board A from here to here, if I switch board A and B, it will be different seating arrangement, but it will be the same match. So in how many ways I can shuffle 5 boards? There are 5 boards. In how many ways I can shuffle them? So the answer is 5 factorial. It means 5 factorial shufflings will consider as one match. So we can divide it by 5 factorial. But still there is overcounting, because if I switch 1 and 2 among themselves, it will remain the same match. Match is still between 1 and 2. If I switch 3 and 4, it will still be the same match. If I switch 5 and 6 or 7 or 8 or 9 and 10, it will still be the match against same opponents. So it means we are overcounting here. So we have to see how many ways we can switch the players. This can be switched in 2 ways: 9 and 10, and 10 and 9, 7 and 8, and 8 and 7, 5 and 6, and 6 and 5, 3 and 4, 4 and 3, 1 and 2, and 2 and 1. So it means these are going to be 2 into 2 into 2 into 2 into 2, which is 2 raised to power 5 ways. So in 2 raised to power 5 ways, they can switch seats across board among each other, but it will consider still be the same combination of matches. So it means we are overcounting 2 raised to power 5 times, so we have to divide 2 raised to power 5 here. So this is all possible matches there. Okay.